You've all heard of a million, a billion, a trillion, a Google. I'm sure that a handful of you have even heard of centillion. But how many of you have heard of a millillion? Or a micrillion? Or a nanillion, picillion, femtillion? Just how far have we actually named these things, and is there any context where it makes sense to use them? Will you be able to make it to the end of the video before your head explodes? Will I be able to finish making this video before my head explodes? Probably not, but only time will tell. So, let's talk about how to name big numbers. I imagine that you're all pretty familiar with some of the naming conventions of these numbers. You're basically just counting how many zeros after 1,000 they have. A million has 1 extra group of zeros, a billion has 2 extra groups of zeros, and a trillion has 3 extra groups of zeros. And as long as you're familiar with your Greek and Latin prefixes, this is pretty simple to continue on. So trideci means 13, or septendeci means 17. These small ones are pretty easy. So 52 factorial, for example, which is the number of ways to arrange a deck of cards, comes out to be about 8 times 10 to the 67. So, to determine what you name it, you first subtract 3 off of the 67. Then you divide that by 3, and now you can name the number. 80 unvigintillion. Viginti means 20, and un means 1, so 21 extra groups of zeros, and you call it 80 because it had a remainder of 1, so that means that it's going to be multiplied by a factor of 10. Another brief example, 10 to the 80 is the estimated number of atoms in the known universe. So, take 80 and subtract 3, then divide that 77 by 3, and you get 25 with a remainder of 2. So, you call this number 100 quinvigintillion. Again, viginti refers to the 20, kin refers to the 5, so 25, and then you say 100 because it had a remainder of 2. Try this out for yourself. See if you can confirm that a Google is 10 duotrigintillion. Now, at this point, it does get a little bit more complicated simply because you have to have more names memorized, but overall, it's not too bad. And you can keep going until you get to a number with 100 extra groups of zeros, or a centillion. If you happen to be a human, you have absolutely zero chance of comprehending how big this number is. According to quantum mechanics, the Planck length is the smallest unit of measure that possibly makes sense. Using Planck lengths to measure the diameter of a hydrogen atom is like using the width of a human hair to measure the diameter of the Milky Way galaxy. There are approximately 4 sexagentillion cubic Planck lengths in the observable universe. If you took one of those Planck cubes and were somehow able to write every number between 1 and 1 Google on it, and then you took the very next Planck cube and wrote every number between a Google and 1 and 2 Google on it, and you kept going until you had done that on every single cubic Planck in the known universe, you would still only be about 4 nanillionths of the way to a centillion. This number does not fit in our universe. Oh, but boy, are we just getting started. After counting off the first 100 groups of zeros, you just keep going. Just use irrelevant prefixes until eventually you get to 1,000 groups of zeros, or 1 millillion. 1 millillion is much larger than a centillion to the 9th power. Remember, 2 to the 9th gets you all the way to 512, and 3 to the 9th will get you all the way to 19,000. Now, even if you multiply a centillion to the 9th power by a Google squared, you are still basically at 0 when compared to a millillion. But of course, why should you stop there? You can always just keep counting off how many thousands of zeros there are at the end of your illion number. So if you wanted to know the name of 10 to the 10,812, for example, you would take that 10,812, subtract 3, then divide that 10,809 by 3, and now you can call it trimillisecentitrillion, named for having 3,603 extra groups of zeros. The number 10 to the 31,299 would be denoted by the moniker decimilli quadringenti duotrigintillion because it has 10,432 extra groups of zeros. Or you could call it a Meyer quadringenti duotrigintillion because Meyer also means 10,000. There's no true standard with numbers of this size, so it all comes down to personal preference if you want to use the Meyer or not. Eventually, you'll come to a number with 100,000 extra groups of zeros, a centimillillion. Keep in mind, a centimillillion is not 100 times bigger than a millillion, it has 100 times as many zeros. A millillion to the 99th power times a centillion to the 8th power doesn't get anywhere near a centimillillion. And likewise, a centimillillion is nowhere near a ducentimillillion, and a ducentimillillion is nowhere near a tricentimillillion. And of course, none of those can even touch 1 micrillion. This number has 1 million extra groups of zeros. If you know your metric prefixes, then you can see pretty easily where this starts to go. A nanillion would have a billion extra groups of zeros, and a yoctillion would have septillion extra groups of zeros. The question that you have to ask yourself at this point is, do these numbers even make sense to use? Yes, they do. I'll give you an example. There are 830 different types of blocks in Minecraft, and one Minecraft world is approximately 1.38 times 10 to the 18th blocks large. To find the number of total combinations, take the different types of blocks and raise it to the power of how many blocks there are. That number ends up being 4 quintillion digits long. So, subtract 3, now divide by 3, which means that this number has about 1 quintillion extra groups of zeros. So, you would call this number 100 addi, tre centi quin quadrigenti femti, centi nana pici, septingenti quin quadrigenti nani, centiduo octogenti micri, tre decimilli quadrigenti octononagentiillion. The exact number doesn't necessarily start with 100, it might start with 200 or 300 or 473. But let me draw your attention to something real quick. If you were to take this octo right here and replace it with nana, this number is 1,000 times larger than this number, because we're counting the groups of zeros. And each one of these groups of zeros has its own special name. So just like how this number is called 1,847,321,482, if you wanted to say the full name of whatever this number actually is, you would have to go down the list replacing octo with septua, then sexa, then kin, all the way down until eventually you get back to the ones place. Now obviously, these naming conventions continue to go on for quite some time. They do not stop at Kekto, but we're going to have to save that for another time. So, if you want to be here during that other time, then you may want to hit that subscribe button so that you don't miss it when it comes out.